move on to some post-processing of this laminate model. In the yesterday's example, kind of just set this up for a modal run and did some modes of the composite version. Let's just remind ourselves here, we're looking at a model that's got a Z stiffener on the outside. I'll turn on my highlighter here. So here's that property. There's my beam elements. We got a couple aluminum plates there in the middle. We got some tubes in the top here, and then we've got a 8-ply property kind of in a thinner section and a 12-ply property out here in a kind of a thicker section. So that's kind of the model we got. So let's do some post-processing. For modes, we could just, obviously just animate the mode shapes, but let's move on to do some actual structural analysis. And what I'm going to do now is in my analysis, let's go ahead and set up the load sets first. So I'm going to create a new load set and just call this plus X acceleration and say OK. And then there's a new empty load set, and what I want to do is throw a body load in there. So I'll just say edit the body loads, and I'm going to put 1G on in the, and I'm using US units in my model here, in the X direction. So that's 1G in that direction, and let's just go ahead and copy this analysis set twice. So we'll go in here and we'll just edit its name. Let's just do plus Y. Sorry to bore you with this stuff, but just kind of get some things set up here, and let's edit that body load, and we're just gonna go and make it in the Y direction. And we'll do the same thing on our Z set. So just gonna click it a second time here and change the title. And the titles are nice just to kind of keep things organized, but go in the body load, open it up, right click and edit. What I'm going to do is just zero that out, hit the tab twice, and paste in my 386.4. So there's my three load sets in 3 different directions. So I'm going to go down to my analyses and say manage. And my modal run's still in there, but I'm not going to use that. I need a static run. So I'll say new. And here under Nastran, here's all the different analysis types you can set up. But let's just do a simple static run. And we have already constrained at the bottom, so we need to do a multi-set run. What I'm going to do is say for this one constraint set, if we had more of these, it would create all the combinations, but there's just these 3. So let's go ahead and create those sets. And then under the output, I'm going to make sure, in case later on we want to do some free body stuff, I'm going to turn on the force balance. And since this is composites, fiber strain is important, so let's turn on strain output from Nastran. So at this point, we're ready to go. I'll just make sure that it was already active, so I could just hit analyze, and Nastran will go off and run here on those 3 sets. And it looks like there it goes. You can actually monitor the Nastran solution as it's moving along here in our little interactive window. So you see Nastran start up. You get any information messages, things like that. You get some solver feedback. And this is probably going to solve pretty quick. It looks like it's already done solving the matrices and do all the back-end processing to calculate all the, I guess, displacement stresses, laminate output data. So it's done. Femap watches it, sees it's done, grabs the results. I'm going to close this guy down. Now it's still looking at the results. All right. So now we got a new study. That's my statics. Sorry, right here. Here's my new study. That's the modes are up here in this study, but statics are down here. So we could take a look at what's going on here and just let's just check the deformation, and we'll turn on a contour. Deformation of total translation makes sense. But since this is laminate, let's get down in here, and there's some ply data. There's ply 1, and there's our strain. So there's the strain in the fiber direction. So this is a pretty important piece of information. So, first thing we just check is, yes, it did go in the X direction, did go in the Y direction, did deform in the Z direction. So it looks like we got everything set up pretty well. Now you might wonder why I did the 1G in each direction. I'm going to show you why. We've got a neat tool in Femap here that we can actually calculate combinations of data or results data. So I'm going to create a new empty data surface that's a result processing. And what I want to do is this will be the data gets created on the fly. So I'm going to do linear combinations and create this stuff. So let's do 6 rows, and you'll see why I'm doing that in a second. And I want to use data from those 3 sets. So you remember that was my set 1 was my X, Y, and Z. So let's say we want to do 5 times the 1G, so that'd be 5 G's in X, and then we'll do 5 G's in Y, and we'll do 10 in Z. Then we'll just do our combinations. So we'll do another linear combination. Let's do -5, 5, and 10. We'll do another linear combination. This is creating new virtual output sets. So we want -5, oops, problem typing there, -5, 10, and then we'll do the same thing down here. So we're going to do linear combination, and let's just match this. And let's just say in negative Z, there's a bigger load, so we'll go -12. So same thing here. Let's just do -5, 5, -12, and then do -5, -5, -12. So that's my combinations. Now what we can do now is we right click and say we create these result sets. So now it's actually creating these linear combinations with these factors. I can close this window now and you'll see that here's our combined load sets with their titles. So I've got all those things, and we can post process on these. So I can look at this one, what's the deformation with those factors applied, what's the ply 1 max or ply 1 fiber stress, and you can just quickly go between these. Now in the laminate world, what you probably really want to do is there's lots of plies. We probably want to do some type of summation. So let's do some max min works. We've got a model output process, and we want to do some enveloping, and I want to see these max fiber strains. So what I'm going to do is envelope all selected vectors within the set. So within each set, it's going to go across all the fiber strains to get me the max min, and then do another one across all the sets. And it's going to ask me what to process. So I'm going to go here and say I want to do just my linear combinations. And then what I want to do is get down here to the ply 1. I'm going to get the fiber strains going. So ply 1, X normal strain. And the nice thing you can do here is if I've picked ply 1, I can say add all layers with the same type thing. So it'll go through, and Femap will just go basically check every one of those fiber strains in the X direction. So now I say OK, and it shows me what it's going to do. It's going to create these max min searches across all that data. So what it's doing now is within each set, it's calculated a maximum fiber strain within that set. So I can go down here, and here's my max fiber strain for all 12 fibers. So there we can see, and it kind of makes sense right down around where it's constrained. You're getting some increases in fiber strain, but that's for that output set. There's for that one. But the real nice thing, it also did it for all of them. So across within each output set, you got the max fiber strain for that set, but then you've also got the max fiber strain down here for all 6 of them. So it's a great way to go through and look at a lot of laminate data. There's a lot more you could do with post-processing reports, and export this data. You can get to it from Excel, but there's no deformation in that set. That's why you're getting that one little error message. Turn off deformation. But some fantastic post-processing options for laminates, for regular elements. Femap's got it all.